Alright, let's look at the characterizations of parallelograms. Alright, so what conditions do we have to guarantee a parallelogram? Right, so that's basically what it is. Right, a convex quadrilateral ABCD is a parallelogram if and only if. Right, first one, two pairs of opposite sides are congruent. So we have that. So none of the parallel stuff is there, but all we know is this two pairs of opposite sides are congruent. But if you draw a diagonal there, right, and you can see that these two triangles are congruent by side because the third side is actually shared. So you have a side. So by using side, we have two congruent triangles. Right? Once you have that, using corresponding parts of congruent figures, so using Z property, right? So let's say Z property here. Right, we could show that these two guys, two opposite sides, are parallel, right? And then we can use another corresponding angles. This angle corresponds to that angle of congruent figures, so we can use the other Z property. So you can use Z property here. Right, to establish that these opposite sides are parallel to each other. Right, so you have two pairs of parallel opposite sides. So we know that quadrilateral ABC is a parallelogram. Right, so we could verify this guy, number one. Right. So number two, this is slightly different. We only look at the one pair of opposite sides, but we require it to be congruent and parallel. Right? So the same length and they are parallel. Right? Then we do the same trick. Just draw a diagonal. Right? By knowing that these are parallel to each other, so we can use the Z property there. So you can see that you see that Z property there. So we have this angle is going to be congruent to that angle, right? Then we can use a side angle side to establish the congruence between these triangles again, right? By the same reasoning, we know that here this angle corresponds to that angle. Then we can use the Z property again to establish the other pair of opposite sides are parallel as well. So we use the side angle side, then use the Z property there, right? So we could verify that we actually get a parallelogram there, right? And another one in terms of diagonals, right? We look at the diagonal. It says that diagonal bisect each other, right? Which means that this diagonal and that diagonal meets at the midpoint. So here, this is the same length as that, and this is the same length as that, right? So then what you can do is you can probably look at this triangle right here, at that triangle right there, right? Because of the these are vertical angles, they're congruent. So using side angle side again, so side angle side, to establish that these two triangles are congruent, right? Then we can have say this is correspond to that guy, right? So therefore, using the Z property again, so this is the Z property right here, to establish that these are congruent to each other, right? And the same kind of deal till, I mean, you can establish the congruence between these two guys. So this is the one, and here's another triangle, right? And the side angle side, same reason. So we can use the z property. So here, so this is the angle here, this is the angle there. So we could use the z property this to establish that these two opposite sides are parallel to each other, right? That would give us a parallelogram. So the fact that their diagonals bisect each other establish that it is a parallelogram. All right, that's it. I hope that this was clear.